Greetings and welcome you all once again for the last lecture of this course, Digital Principles and its Realization using Python and Tinkercad. So in this lecture, we are going to see about how to design and realize programmable logic array using Python and Tinkercad. This is a very important lecture since we are going to see what we didn't see earlier. So previously we see some Tinkercad logic ICs we are taking and then we are connecting and we are realizing. But here we are going to write program in Tinkercad itself and we are going to realize what we are actually working in a theoretical manner that we are going to see both in Python as well as in Tinkercad. So ultimately this will be a beginning of many digital principles. So I just continue with this. So this is a programmable logic array. So programmable logic array, previously we see programmable array logic. Now we are seeing programmable logic array. So programmable logic array is nothing but both AND gate and OR gate are programmable. Since in logic arrays, we will have two boxes. One contains AND matrix and another one contains OR matrix. In programmable array logic, AND gates are programmable and OR gates are fixed. Whereas in programmable logic array, both AND gate and OR gate are programmable. This is the ultimate difference between these two logics. Now, for explaining this, I am just taking a Boolean function sigma m is equal to 1367 and 0245. Just here two functions I am taking for analyzing these things. So here you can see here they have given minterms. So what we have to do, we need to write table for this. So two functions only, f1 and f2, and three variables are involved, a, b, c. And we all know that programmable logic array is nothing but we have to program both AND gate as well as OR gate. So what I am doing is first I am going to write the truth table of this logic. So first I am taking a, and another thing I am taking b. This is not functioning. So let us do one thing for clearness. I will draw a table then so that you can understand. One is for A, another one is for B, and another one is for C. One is for F1 and another one is for F2. So I am increasing. After that, let us check. Okay, this table will help you better. So what I am doing, I am keeping here. First one is A, next one is B, next one is C. Functions are F1 and F2. So now I am going to write the things 0 and then 0 and then 0 and then 0 0 1 0 1 0 0 1 1 1 0 0. Okay, I think this moves right, and then 1 0 1 1 1 0 following by 1 1 1. I think it is clear. So first what I am going to do is I am going to fill up this table. Already in the last lecture itself we explained how to fill this table. What are all the minterms associated here? We need to mark 1, otherwise we need to mark 0. So 0 is not present, so I am keeping 0. 1 is present, so 1. 2 is not present, 0. 3 is present, 1. 4 is not present, 0. 5 is not present, 0. 6 is present, 1. 7 is present, 1. Similarly for F2, what I am doing, I am keeping the same thing here. For starting from 0, 0 is present 1, and then 1 not present, 2 is present, and then 3 is not present, 4 is present, 5 is present, 6 is not present, 7 is not present. That's all. My work is over. You can see here how the table is clear. Now what I have to do, I need to draw the Karnaugh map. So how to draw a Karnaugh map? You all know, right? This is a 3-variable Karnaugh map. So 0, 0 is 0. For F1, I am writing. So here, this is A and this is BC. That means this is B bar, C bar, B bar, C, B, C, B, C bar. And this is A bar and A. So what I have to fill? 0 is 0, 1 is 1, and then 3 is 1. That also you can take and directly fill. 0, 1, 3, 6, 7. So 6, 7 means where it is 4, 5, 6, and 7. So these two things are mapped together. These two are pairs. So what is the answer for F1? F1 is equal to, from this I will get A bar C plus this one is A B. So F1 is equal to A bar C plus AB. This is the first function. And similarly, I need to draw another Karnaugh map for F2. This is for F2. F2, 0, 2, and then 4, 5. Just verify. 0, 2, 4, 5. What I have to map? These two are pairs. These are two are rollings. So F2 is equal to what I will get? A bar into C bar plus A. This one is B bar. That's all. Two functions. F1 is equal to A bar C plus AB. F2 is equal to A bar C bar plus AB bar. Now what I have to do? I need to draw the diagram. First, what I have to do? I will fix A, one straight line, and then B, another straight line, and then C, another straight line, and then A bar, inverted line, and then B bar, another inverted line, and then C bar, another inverted line. Same thing, right? So here what I am doing, I am taking one line. What F1 function, what is involved? A bar C. So what I have to do? A bar and C. I am crossing this. I am writing the answer A bar C, and then I am giving it to a AND gate. This one over. Next AB. AB means A and B. Shorted input AND gate. Then I am. Next one is anything is repeating now. So you have to draw everything only. A bar and C bar. This is shorted, and I am writing. And finally, this last term, that is AB bar. So A and B bar. So shorted. So write better practices. You can write. This is AB. This is A bar C bar, and this is AB bar. There are programming tables are there that are all you can learn in a better manner whenever there is necessity. But without programming table also you can identify, and directly you can draw the diagram. No issues. So now what I am doing, I am shorting this two terminals, and I am giving it to a OR gate. Shorting the two terminal and giving it to OR gate. First one is called F1, second one is called F. Fine. Now what I am doing, A bar C means I have to cross this, and then AB means I need to cross this. So here you can see this is also programming. We are also programmable. Already this structure is available. Just you need to fix the fuse wherever you want. Right. Next. F2 is equal to what answer you are getting? A bar C bar plus AB bar. These two things. So I am. So what is our ultimate aim? We need to get this table, and we need to verify whether this F1 and F2 are responding according to these inputs. So we are going to do this program in both Tinkercad and Python, and we are going to verify. That is our task. Okay, I think theory part is clear for you. Now I am going to take you to this the programming part in Python. You can check here. This is the same thing, same program. Definition, PLA simulator. Three functions are involved, A, B, and C. So what are all the things we are doing? Check this. F1 is equal to A bar C plus AB. So check here, A bar. So what I am doing is, here you can see, here first I am writing AB is equal to A and B. A bar C is equal to not of A and C, like that. So what are all the things available in the function? First I am writing AB is available, that is A and B. A bar C is nothing but not of A and C. This is not of A and not of C, and this is A and not of B. These are all the things we have to do. So same thing I am doing here. AB not AC, that is not of A and C, and then A B bar, that is A and not of B, and BC is nothing but directly B and C. BC is coming, BC is not coming, but why it is written I don't know. We will check that. Okay, so BC, I think anywhere BC only, nowhere. So only we are having F1 is equal to A bar C plus AB plus A bar C bar plus AB bar. These are all the things. So let us check. This is for different programmable situation I do. F1 is equal to AB plus A bar C and AB bar plus BC. They are getting like that. So this is A bar C plus AB, A bar C bar plus AB bar. So we have to write these things. What is the missing term? You need to identify. A bar, B bar plus. Otherwise, we can use the simulator. What function they are having, we will take and we will do that also. Otherwise, we have to rewrite the program completely. No problem. A and B not of AC is equal to AB plus A bar C. That is okay. AB plus A bar C is okay. A bar C bar plus AB bar, that is the difference. A bar C bar plus AB bar. So A bar C bar. Okay, this is A bar C bar, right? A bar C bar. A bar C bar plus AB bar. AB bar. So we need to write these things. AB bar I need to write. So what I have to do, I can write A B bar. B bar means not B. A underscore not B. That means what I am writing A B bar, right? So A and not of, right? So now F1 is okay. F2 is equal to A not C or A not C, or this is small c only, or A not B. That I need to write here. This comment you don't see, A not B, right? So these things I am removing just for reference I written. So this is nothing but A not C. This is comment just for our understanding. Okay, and then A not B. Right. Now you can see remaining all are same only. A, B, C, F1, F2. Here you will see one new thing. Print hyphen star 13. Why this number 13 means this small star will repeat 13 times, so that a straight line will come. Instead of putting dot 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 dot, I am just writing star 13. That means it will be directly come repeat 13 times and you will get a straight line like this. So remaining all are same, nothing is there, just I replaced the commands. So remaining all are at most the same, no problem will come. So I just rerun the program. Okay, this is some login issues. So this is the program what we are going to run one more time. I am using in my own admin login. So this is the complete diagram what we are. So first I will connect here. So this is not B, A not B plus or BC is coming. So it is not reflecting here. So I will just copy and paste here so that it will come. Okay. So from here I need to copy, right? A not C and this things. A not C. Right. A not C. Right. I think it is okay now. Just everything. If once connected means it is connecting. Once it got connected means we will run and verify whether we are getting the same truth table what we have written. Otherwise, we need to do some small modification. I think it will be correct. So what are all the tables I am writing here? Same thing you will get as answer. A bar C plus AB, and this is one is A bar C bar plus A B bar. Right. So according to the program we have written, but what is the things we are having? Let me check. Okay. So this is connected. Now what I am doing, I am just running the code. Okay, some technical problem is coming. I think so. What problem we will keep? So answer not C is not defined. C is not defined means capital C they have given. I have given small c, that is the problem. So I am replacing this capital C, not of capitals. And here also not of capital C. Automatically it will show all the errors. Only one thing is we need to understand the errors, right? So I will run the coding once again. Now it is coming. You can see what are all the things. 0 1 1 0 0 1 1. Same thing, or 0 1 1 0 0 1 1 1 0 1 0 1 1 0 0. So F2 is not respond. F2 is totally different. F2 is totally different. So we need to check the F2. A not C. Okay, here you can see here A B bar, A bar C plus A C bar plus A B bar. That is the answer you are getting, right? A C bar plus A bar C bar plus A B bar. A bar C bar plus A B bar. That should come. A bar C bar plus A B bar. Okay. A bar C bar plus A B bar means I have to give like this. A bar A bar B bar plus AC bar. A bar C bar plus AB bar. Okay. Sorry. A bar C bar plus A bar C bar plus AB bar. Okay. A bar A bar C bar plus AB bar. Now it is correct. A bar C bar plus AB bar. Right. A bar C bar plus AB bar. Now I have rewritten the coding. A bar C bar plus AB bar. Right. A bar C bar plus AB bar. Here A bar C bar I have to write. If you want you can write, otherwise for variable there is no problem. So otherwise you can write not B, like that you can write not A. So here also I will write not A. Not A, not C, A bar C bar plus A B bar, like that I am writing. Okay, now I will run the coding once again. Right, now you can check 101 1100. Whatever we are writing, it will come 101 0 1 1 0, right? 101 0 1 1 0. So this is the case. So test case also I have written. If you check 101 means F1 is equal to 0 and F2 is equal to 1. This is the test case. If you test that means it is giving the answer. So it is working. So now Python part is over. Okay, whatever we are, I think I lively demonstrated what are the changes you have to make, how to make the changes also I have lively demonstrated. I think you understand. So starting from the first lecture and up to this last lecture, we have followed the same pattern. We didn't change even a single line. So same definitions only. We are again and again doing and completing the course. Only one new thing is this small hyphen star 13. That means this will repeat 13 times so that you can get this straight line. That is the only thing I have done a small change. Remaining all are as it is, right? So Python we will close successfully. Next we are going to take this portion that is called as Tinkercad. That is very, very important, very, very useful also. So this is called as Arduino board. Everyone knows that, I think so. Arduino, if you type means you can get this board Arduino Uno R3. This is a very hand-picky processor used for realizing anything, even sensor level also you can work with this. So this processor contain digital pins like this. Usually this pin can be used for reading and writing purpose. So already all these pins are connected with 5 volt internal. If I start the simulation means what you will have means this will be plugged in and all these pins are connected with what 5 volt internal. These are already 5 volts are available here. So how to make use of that? That is the only thing. So what I am going to do is I am going to show you the code, how to write the code. That is important. Already I have written void setup. This is the body. And here I can use pin number 2. Here how many pins are there? Starting from 1, you can use up to 13 pins here. So you can closely watch this. Slowly you can realize. Okay, so I will drop here and I will enlarge this. You can see here one thing you visualize. Okay, so here you can see one tilt symbol. That is very, very important. Where we are using the tilt symbol, you understand. Some portions are tilted and some portions are not tilted. You can see here 9, 10, 11. Tilted portion means what means? It is called as internal pull-up. Internal pull-up means all the things are connected with high-end power supply. You can use the something it is inverted, some case it is directly connected to power supply like this. So in order to avoid that, what I am doing, I am assigning the pins 2, 3, 4 for A, B and C. So I am giving it as pull-up. Pull-up means what? Directly connected to power supply. Input is directly connected to power supply. That is treated as 1. So next what we are doing, pin mode 5 and 6, I am calling it as output pins. These are going to serve as F1 and F2. Then serial begin, this is optional. If I want to view the text base means you can use this text mode output, right? If I run means I will show what is this serial begin. So serial monitoring is possible. So for that purpose, I am using serial begin 9600. 9600 is the data transfer rate or baud rate. Like that. Those who know digital electronics well and data transfer protocols, they can able to understand what is meant by this serial begin. And what I am doing is here the important thing is int a is equal to not of digital read of 2. See here this 2, 3 and 4 are for reading purpose. That means we are going to give inputs from switches. That's why we are calling it as digital read pins. I am putting one not symbol. That means initially all the pins are pull up. Pull up means maintained in high level. So initially what we want in the Python, you can see initially everything should be 0, 0, 0. That means we have to invert the pins. So that I am using this inverter symbol and directly I can write all the things. Int AB is equal to A and B. Not of AC is equal to not A and C. Here also not A bar B bar. So what I have to do, I need to put here also one not symbol, right? Not A and not B. Here I need to put AC bar. AC bar means what I have to do, I need to put here instead of BC bar, I can write A C bar. That means A and C bar, right? Equation is correct. A and C bar. A bar B bar, A B bar plus A bar C bar. A B bar plus A bar C bar. So A B bar, sorry, here A B bar plus A bar C bar. So what I have to do, I need to replace this A bar and C bar. So this I will put one cap symbol over this. So A bar and C bar. So this is A bar, and then C bar is not coming. So I have to do one small trick here. So these things, this variable upper script that are all, if you listen through the Arduino coding means, you can able to get this, but I am not interesting. So what I can do is, better I can remove this completely. Okay, and then I can write according to this A and C bar, right? Otherwise, this is so this is called oversight. Oversight means what? Means there is no top button. I will put one underscore, and then I will write not A underscore not C. That is A bar C bar. What is the misunderstanding means this small hyphen is looking like A bar and C bar. That we don't know actually. If a library is available means someone may also use different libraries, so we don't know. So that's why we are confused. Okay, now A B bar plus A bar C bar, that is done. So remaining all are as it is. F2 is equal to AB not AC, and this one is A not. So this is also A bar B bar, right? So I have to write not of A, and here not of A now. This is A B bar only now. A B bar plus A bar C bar. Little bit confusion. A B bar plus A bar C bar, right? A B bar plus A bar C bar. So not of B is not a problem. Here only I need to write BC not. Instead of that, I need to write not A underscore not C. Whatever the program whatever I am writing here, I am just copying. Not C is capital C also. Anywhere capital C is missing means replace, otherwise it will show errors. Since declaration is ABC. This double and symbol, and totally we are adding all these things. Or symbol. And then digital write of 5, F1, 6, F2, all the things are okay. And delay 1000 means we can able to realize the output like that. So every 1 millisecond, 1 second, that is 1000 milliseconds is equal to 1 second. That serial monitor will wait and print the next thing. That's for that only I am introducing delay. So now the program is over. Now we want to do connection. Program, I think, understandable. First, you need to declare what are all the pins to be acted as input, what are all the pins to be acted as output. And if you want serial level monitoring, here you can see one serial monitor, right? If you click that means you can see the numbers are coming. Whatever we are giving, that we can test here. And then ABC digital write. So initially everything is held high. So we are inverting this, and we are assigning it as 2, 3, and 4. And we are writing the function as it is. And then what we are doing is we are going to see what is the result coming, right? Let us check. So this coding portion over. Now what I am doing is I am going to connect this. How to connect, that is important. So 2, 3, 4 are connected as input, and 5 and 6 are connected as output. So what I am doing is from the 5 volts, here you can see one 5 volt is available. So I am taking that 5 volt and connecting to one common point here. This is small breadboard. Initially we take big breadboards, but here we are taking very small breadboard for our understanding. So next what I am doing, I want to connect this to lower part of the switches, this one, and from A part this is. Next I am taking and connecting it to another thing, randomly only I am connecting, right? And then third part I am taking and connect. You just follow in a systematic manner. Don't jumble the connection, you will get confused. So 3 switches I have connected. So from the top portion I am taking, that is called A. So what I am doing is I am taking one wire from here and I will go from here to here. From here I will come here and I will connect here to second pin. For avoiding of confusion, I am taking this long route. So from here, second pin is B pin. I am taking here otherwise, and then I am connecting it to third pin. 2, 3, 4 we connected now. So 2, 3, 4. Third pin. And from third pin, I am taking one wire and connecting it to C pin. So here, driving here and connecting it to third pin. Finish. And then 2, 3, 4 are connected, 5 and 6 are output. So what I am doing, from 5th pin I am taking one wire and connecting it to F1 or LED. Which one is F1 we have to assume. So first LED I am assuming is a F1. So I am connecting here, and from 6th pin similarly I am taking one more wire and connecting it to F2 section. F2 section. Next what I am doing, I need to connect ground. Okay, so this ground, so for this purpose I am going to explain you one important concept. Remember, this 5 volt, if we are not using pull up in the code, we have show you one concept called pull up. That means initially it is connected to which point, 5 volts already internally connected. So again we are giving 5 volt means it will give reverse result. So what I am doing, one ground point. So that means this 2 volt is now connected with power supply, and ground point is we are connecting here. That means internally it is connected to plus and we are connecting minus. That means circuit will be ended. So another ground I am taking and I am giving it to negative of the resistor. So these points you have to understand. This is where we want technical human intelligence. So these two are interconnected. So 2 grounds are made. Any other ground, everything is done, right? So this is the connection. That's all. Now we are having 3 points. One is A, another one is B, and another one is C. If I start the simulation, it has to work. That's all. So if you just start the simulation, the light will start glowing. Now we need to verify the output. If all are 0, 0, 0, then what happened? 0, 0, 0 means result should be 0, 1. Coming right. Next 0, 0, 1. 0, 0, 1 means 0, 0, 1. That means what happened? 1, 0. Fine. Working. And then 0, 1, 0 means what happened? 0, 1. 1, 0, 0, 1, 0, 1. So we have to check these 2 points. 1, 0, 0 and 1, 0, 1 we will check so that it will be same result. So first I am giving 1, 0, 0, that is 0, 1, 1, 0, 1, 0, 1, 1, 1, 1, 1, 0, correct? 1, 1, 1, 1, 0. Clear? So within the simple connection, I have realized one programmable logic array. What we have discussed here, what I have drawn here, this entire diagram is now fused here. Inside this processor, this diagram is now fused in the form of this program. This is how we are writing the program. So this is the equivalent program for what we are seeing it in the Python. So many converters or even Google Gemini is available. if you give this coding and if you ask to it to convert to equivalent Arduino means it will do. Automatically it will convert and give it to you. But you need to check only all these parameters, what I did not get, and according to our function, everything is available or not. And these 2, 3, 4 functions and connecting ground to the power supply, reverse operation, this thing only you need to be a little bit careful. So here serial monitor is available in the code section. If you click means what is the final result, it will produce for every 1 second. Every 1 second duration, this will keep on repeating. If I change anything means that will be repeated. For example, if I am changing, this is what happened to this. All are 111, right? I am changing it to 110. 110 means what happened? After a particular second, you will get 110. That means F1 is equal to 0, F2 is equal to F1 is equal to 1 and F2 is equal to 0. What we have, right? So this is how we are realizing a programmable array logic by programmable logic array by using Tinkercad and Python. Hope this lecture is little bit, so as the promise from the starting to ending, we are giving you a stuff related with both Python as well as real-time implementation results also. In this, as a extra advantage, we are teaching how to program a Arduino also. That is additional benefit for the learners who are learning this course. So with this, after a long journey, we are completing this course model. So with this, I am concluding this course. So in the upcoming courses, you will have some welcome messages or something regarding my next course on different modules which are currently trending and which need realization of the real-term practices. In that, definitely we will make. So hope this course is very much useful to you. I wish you all the best in your learning career. Have a great learning ahead and wish you all the best of luck. Thank you very much.